Welcome. Today we will be talking about ketones and aldehydes. So first we need to know what a ketone is and what an aldehyde is. These are two different types of functional groups. So a ketone, basically, we have a carbonyl and it's bonded to two different R groups. So let's just make it R1 and R2. This is a ketone. An aldehyde looks very similar, except instead of one of these R groups, we have H. And that gives us an aldehyde. And if you find yourself getting confused between the two, what a ketone is and what an aldehyde is, a fun mnemonic that I like to use to help me remember this is the fact that aldehyde has an H in its name, and in an aldehyde we have a carbonyl carbon bonded to a hydrogen. Ketone, there's no H in its name, so we know this is the one with two different R groups. So that's a fun way to remember it if it might help you. So one important characteristic of both ketones and aldehydes is the fact that we have a dipole. We have a dipole because this oxygen we have over here is more electronegative than the carbonyl carbon, which is over here. So it's pulling that electron density away from the carbon and towards itself. And it's even stronger. It's even stronger because the carbon is double bonded to the oxygen. So since we have a situation in which we have a carbon double bonded to an oxygen, that means we are more oxidized. So both aldehydes and ketones are pretty oxidized because they have double bond to an oxygen. Now, if we compare this to an alcohol, say we have this secondary alcohol over here. Which one is more oxidized, the alcohol or the ketone or aldehyde? So if you said ketone or aldehyde, you are correct. And another way to remember this is that oxidized has an O, and if it's oxidized, it has more bonds to O. So oxidized, O. Oxidized, more bonds to O. If we look at alcohol, we only have a single bond to an oxygen. So this is the reduced form of a ketone or an aldehyde. So we can get an alcohol from a ketone and an aldehyde. We just have to reduce it. So we have to reduce it. And we can reduce it by using reducing agents such as either NaBr4 or LAH. We can use these. Now, if we oxidize an aldehyde or a ketone, what can we get? So if we go the other direction and we oxidize, which again means we're adding more bonds to oxygen, we will end up with a carboxylic acid. So if you look here, we have double bonded to one oxygen over here, and we have a carbonyl carbon single bonded to another oxygen over here. So we are more oxidized because we have more bonds between the carbon and the oxygen. So just to reiterate, we have ketones and aldehydes. We can go from aldehyde or ketone, we can reduce that and we can get an alcohol, or we can oxidize going the other direction and we can get a carboxylic acid. So again, we can use oxidizing reagents. An example of that might be KMNO4, or we can also use a Jones reagent. So there are multiple different possible reagents that you can use to get from ketone or aldehyde to a carboxylic acid. Now, if we go back into the reduction and we end up with our alcohol, you might notice here that we have a 2' alcohol. And I use that as an example just to group up alcohols in general and how we can go from an alcohol to a ketone or aldehyde and vice versa. But in this situation, I specifically drew a 2' alcohol. So what does that mean? Can this become specifically a ketone, or can it change between itself and an aldehyde? So the fact that we have a 2' here, we have two separate R groups on the side, right? So what does that look like? That looks very similar to a ketone. So if we have a 2' alcohol, we can oxidize it into a ketone. And if you guessed that if we have a 1' alcohol, so a primary alcohol, that we can oxidize it into an aldehyde, because we have only one other group. We only have one other group on that side. So that's why we can get an aldehyde from that. Now, so we have 3 groups here. We have ketones and aldehydes, which are our main focus right now. We have carboxylic acids, and we have alcohols. So going up means we're oxidizing, and going down means that we're reducing. So which one of these do you think has the highest boiling point? So if you guessed carboxylic acid, you are correct. So highest boiling point. An important observation that you should use, that you should have made over here, is that carboxylic is the most oxidized, and it has the highest boiling point. So the kind of connection that we need to make here is that more oxidized means higher boiling point, because it is stronger. It is stronger and it's more polar, which makes it harder to break apart, and it makes it harder to mess with it. So it has a higher boiling point. Ketones and aldehydes, we still have our double bond to oxygen, but we are missing that other 3rd bond to oxygen. So we are less oxidized over here than carboxylic acid, but we are more oxidized than these alcohols over here, in which we only have 1 single bond to an oxygen. So least oxidized equals lowest boiling point. And we have ketones and aldehydes right here in the middle. But what about ketones versus aldehydes? So I have them both drawn here because, for this video, we decided to start off with ketones and aldehydes and build off of that. But which of these two has the higher boiling point? So we can see here that we have carbonyl carbon on both, so that's even. But what do you see that's different between ketones and aldehydes? And the most important thing that you should have noticed is this hydrogen. So just like we said, more oxidized means more bonds to oxygen. More reduced means more bonds to hydrogen. So more oxidized is more bonds to oxygen. More reduced is more bonds to hydrogen. And I don't see any bonds to hydrogen in this aldehyde, but we do have a hydrogen over here, in this ketone, but we do have a hydrogen over here in this aldehyde. So therefore, using the same, knowledge that we used earlier, since the ketone is more oxidized than the aldehyde, it has a higher boiling point, and the aldehyde has a lower boiling point than the ketone. Now, which of these two do you think is more reactive? So again, we know that our carbonyl group over here is the same between the two. So we're going to have to look at what the carbonyl carbon is bonded to. Over here we have 2 R groups, and these R groups can get quite bulky. And over here we only have 1 R group, and then we just have a singular hydrogen. So that makes the aldehyde more reactive. It's able to react more because just physically looking, it has more space, whereas the ketone is more sterically hindered. And this is due to the fact that we have 2 different R groups. So that makes it more sterically hindered, and it's less reactive. And less reactive means more stable. More stable, again, gives rise to that higher boiling point. It's harder to mess with the ketone than the aldehyde. So there you have it. There's a basic overview of ketones versus aldehydes and how we can kind of get from ketones and aldehydes to carboxylic acids and then to primary and secondary alcohols.